there's a series of cooling ponds which were used for storing and processing spent fuel rods. These have been out of service for a number of years and are in quite a poor state of repair now. There's a plan to carry out decommissioning of these ponds by using ROVs to remove the spent fuel from the bottom. Unfortunately, the access port that the ROVs would come in through has been blocked by a stainless steel frame which has become jammed in the doorway. So through the LINK programme, Sellafield offered a challenge to provide a piece of cutting equipment to size reduce this frame to remove the obstruction from the doorway and allow access for the ROVs. We considered about half a dozen different cutting technologies, looking at all the requirements of the project and the constraints. It was quite a difficult challenge. It was a long way away from where the operators will be standing, about 5 metres. It's under 4 metres of water. The water is both contaminated with radioactivity and it's a very high pH, it's about pH 11.5, so it's a highly caustic environment, so that limits the materials that can be used. So diamond wire seemed like the best option given all of these various constraints. It's quite similar in some ways to an ROV, even though it's mounted on the end of a pole. It's deployed remotely, and once it's attached to the workpiece, it's left in place. So it has a lot of crossover with ROV technology. So the main elements are a gripper, which secures the machine to the workpiece, a linear slide mechanism which moves the wire into the workpiece, and then the diamond wire pulleys and motor which affect the cutting. On the back of the machine there's a hinge joint to allow positioning and orientation, and then the deployment pole, which is 4 pieces of 2 metre long sections to give an overall 8 metre length deployment pole. We developed a test rig initially just to prove feasibility and to get a feel for how the cutting process performs and what sort of parameters we might have in terms of cut rate and overall duration. So the diamond wire cutter is a great solution for this particular challenge at Sellafield. It's relatively unique. We're not aware of anything else that's quite like this at Sellafield or in nuclear decommissioning in general. Some of the benefits include the very low reaction force, so you can work on a workpiece without particularly having to push against it. There's low disturbance, so if there's sludge or other materials nearby, they won't get all swirled about like you might have with an abrasive saw, for example. This particular tool is designed for underwater use, and it's been made neutrally buoyant, so it's particularly easy to handle by the operators, even at a very long reach. In this case, we had about 4 metres depth of water and then another 3 metres up to the operator's position. We got really good feedback from the operators who used it. They were really pleased with the handleability and the ease of manoeuvring the tool, even though it's at a very long distance from where they were standing. So you can see lots of opportunities for this particular tool in other parts of Sellafield. The current machine is configured for cutting flat bar, but it could be easily modified to cut through small bore pipe work or round bar or hollow sections of pretty much any size with appropriate modifications.